power plant and so on. But we should look at infrastructure as an interconnected system, which I will have some later slide to focus on the system approach, which we very much needed. So this infrastructure system very much form the backbone of the functioning of the society, from basic connectivity to migration, climate change, and touch every aspect of human life, from very basic service I mentioned to different kinds of the human activities. The record getting clearer that very major contribution of about 92% of infrastructure system, not only one, very much contribute to the target across different 17 SDG. This is quite remarkable. Obviously, we cannot guarantee, but this could be a kind of potential. And there are some ongoing research, including at AIT and other university, try to verify and then look at specific linkage from the infrastructure to the sustainability. In particular, the infrastructure connects population with education and could be also about the job opportunity. Also drive economic growth and job creation. I think there are some basic linkage among this. And last but not least, also reduce the inequality, also sustain some of the positive effects, including like peace. From the built environment point of view, as mentioned, this could be a bit broader. We can say that built environment is where we live and spend most of our time, which become quite significant because we moving around on our space and we rely on different types of the built environment. And a simple definition of sustainable built environment included here should be circular, which is one of the key parts that we may want to look at. A design for longevity, for the maybe longer life of the people, flexibility, adaptability, assembly or disassembly, continue with the reuse recoverability, and consider future risks, including the climate. So some of this we can cover in today's talk, but obviously we could continue to link into any of these good holistic linkage. These are some of the examples which might be good to see from what the picture here can maybe provide the meaning. The upper pictures could show example of how specific infrastructure. This is in fact a tidal power plant, which I think you can find this kind of growing types of infrastructure, which very much linked to the natural resources. In this case, it would be like coastal water or any kind of coastal resources, which is one of the things that typical from the linkage of infrastructure to the ecology. The upper right picture shows the linkage of basic infrastructure, not really basic in some cases, but this become growing into the mass transit system. Link with the passenger, with the people life, with the human activities. Then the lower pictures here also demonstrate some kind of emerging risks. The left hand bottom picture is that coming from our own AT campus. Many colleagues, participants joining here might be familiar with. We had this more than 10 years ago, and Yeah, this also show that our built environment example of the campus could be very much exposed to a different kind of the disaster or the changing environment. And another one at the bottom here also show the linkage of the industry or the could be power plant to emit some kind of pollution, which also strong linkage to the environment. What we perhaps like to look at this point is also mentioned earlier, how the sustainable infrastructure can be connected to different SDG. And yeah, this is kind of a very conceptual types of linkage, but could also go into the empirical or the real kind of the interconnection. It's good to see that how infrastructure from the sustainability point of view could deal with what we call the inclusive growth on the left hand side here. So there could be at least a number of SDG mentioned here, which could be more according to the infrastructure development. Not all this become the positive relationship. Some might be a bit negative. That's maybe part of our job to look at from understanding and try to manage. The other side is about basic service. As mentioned, at least many infrastructure provide this basic service in a traditional way. So this could be very much related to many SDG from what we call the social sustainability. And at the bottom, the linkage into the environmental sustainability, also a number of SDG could be also looked at. Each of these linkage should not be looked at as isolation, because in our real life, we are not dealing with one by one SDG or even one by one a piece or element of the infrastructure. So we will also move on to look at how we look at the bigger picture and then try to see any interconnection from different dimensions. To be more specific, if we look at on this slide, we call the low carbon climate resilient infrastructure when we want to connect to any of the SDG. So in this case, could be a bit specific or subset of the broader infrastructure like in the previous slide. So in this case, there could be a more specific SDG mentioned surrounding this low carbon infrastructure. And the specific linkage can be in specific with a specific SDG like education from the public transport and mass transit system as example. The infrastructure with the food security SDG 2 regarding efficient irrigation, resilient transport could be kind of research interest of any of the participants joining here, and other. So I will not go to all of this. But this could be part of the way forward, how we see any gaps, any challenge and opportunity to see kind of a clearer linkage. And obviously that would contribute to our better management and development. Let me show a particular example, in fact, based on our former student research from Indonesia. To analyze factors influencing urban heat island in the city of Surabaya, big one in Indonesia. Luckily, students could obtain a lot of the secondary data, and this is a basis on this research, including the temperature shown on the graph here, among a total of the 3 stations, to justify how the temperature different among different locations in this particular city. And a simple statistical analysis, many of audience participants familiar with this could support the analysis of relationship for the certain urban heat parameter and a number of the possible factors that might influence. And this is quite good that finally, among a large number of factors, end up with about 5 factor mentioned here to see how this have more significant influence on the urban heat island. And in fact, this research is a master's thesis of our student and only published in this 2016. Also turned into possible measures utilizing this understanding of the strong relationship. Like on the picture here, the basic increasing of the green area, including in the middle of the road, could contribute to this maybe less risk from the urban heat island in the city. The second part that I'd like to cover would be about the situation and trend. Yeah, we may look at from different angles, from many criteria, indicator to look at. But the simple way I like to offer here, starting from the first group, we call the driver or the pressure. In some of the analysis might separate this, but I try to simplify that. What would be a key driver and pressure regarding sustainable infrastructure and the built environment? So to summarize, at least I see that there are different types of the risks, obviously coming from basic natural disaster, but some of these could also contribute to the human types of the activities, including like climate change related risks. So we can also look at the second group is about socio-economic development, which could affect the infrastructure and built environment from the basic GDP, population change, and also the dynamic aging types of the society. Then the next one, this could be more on the pressure regarding urbanization and land use change, particularly the built-up environment and space, which strongly related to the infrastructure. And the last part on this is about the changing demand and some challenge in terms of funding. I think these are kind of the big topic in terms of increasing or somewhere we want to look at diversity of both the demand and also the funding challenge and opportunity. From the state or the impact, maybe to help look at the trend, at least we could look at from the loss and damage following the different type of the risk. And infrastructure are quite so serious. There are many research, including some of our own, to utilize the loss and damage with some kind of gap filling we still need to do so that we can use this one to justify the possible improvement. The next one is about the greenhouse gas emission and changing climate. From what we know now, the increasing greenhouse gas emission from also infrastructure development. What would be very important changing climate parameter from the temperature and others. And the next one is about the economic, which also important, was any of infrastructure built environment. We have to be subject to, for example, affordability, including level of the efficiency. I think we cannot live with really low efficiency, for example, and there could be some good room to look at from the efficiency point of view. And important from the both resources and pollution from the environment. And these two specific ways to look at from this part, resource consumption and the pollution types of the emission. And the last one from the social, including like equality, livelihood, and well-being, at least from the social infrastructure, but also other type of infrastructure could be looked at from these types of the state or the impact. Yeah, all this could have some supporting information, and I believe audience are familiar with at least some of this. So I will just skip some detail and look at some of the slides to show example of what mentioned in the previous slide. The first one here regarding urbanization. And this is both historical and prediction by UN Habitat, which is the key agency dealing with the urbanization from different parts of the world. If you are in Asia, maybe we can say that both good and bad news. The good news, obviously, the red color, in fact, is very much significant rate of urbanization. Yeah, obviously, many of audience might see this as a good news. I mentioned enjoying whatever from urbanization, maybe better infrastructure, better basic service, better connectivity, and so on. But at the same time, as we realize, there could be some bad news regarding negative effect of the urbanization. Then this shows some of the key consequences of the urbanization from the percentage of the people living in the urban area, which followed the trend in the previous slide. And then we can look at the basic solid waste, very much falling the population. And also another factor could be the rate of generation per capita or person. Then obviously the material consumption also very much strong to link to the infrastructure development would be very much growing. Also dealing with the resource extraction from basic food, maybe going to the construction or any input into the infrastructure. And we could also look at from the energy and then to the greenhouse gas emission. Not just only following the size of the population, like the waste generation, but this could also equip with depend on the per capita consumption of the energy and also the greenhouse gas emission in the urban area. In terms of climate change, this go into a bit detail. Good that this latest publication from IPCC try to convert what we understand from the climate change. Yeah, obviously there are kind of scenario or the trend regarding the increasing temperature from very past to the current one, and we are reaching maybe somewhere close to 1.5. And there are some target, but obviously the scenario here can continue to at least we might see the possibility to have about 4 degrees Celsius by the end of the century, subject to some of the ongoing efforts. But this turned into from the greenhouse gas emission and scenario, how climate change could affect the first part on the left-hand side is about if we see wetter environment, in other words, about heavy precipitation in every 10 years period. So what will be a kind of the frequency? And we can see that this is clearly to understand that increasing frequency according to the higher change of the climate, following basic the surface temperature. Similarly, on the right-hand side is about the drought, which could affect basic food production and others. Similarly, in terms of the scenarios, and turn into the increasing frequencies from only once, take as a base, what would be the change in the increasing temperature in future. And yeah, any of these are quite strongly related to different types of infrastructure. If the engineers or professionals going to plan for a basic water supply, flood control, or even hydropower, any linkage from what we are talking about in terms of the water of the too much and maybe too limited water to have effect on different types of the infrastructure. So I think this is a clear example, and we have many things to do based on, even this is not 100% to happen, but it's a basic thing that we normally utilize for our planning and design of the infrastructure. Similarly, if we want to link this type of the risk, we normally call like hazards, and in fact, this is the multiple hazards. How this link into the spatial distribution of the city or urban centers. That would be another way to look at, because there are at least some part of the world and many in Asia. We see that more urbanized and then maybe more growing mega city. But at the same time, there could be some area also subject to or exposure to higher different types of the hazards and turn into the possible risks, particularly in the South Asia here and many in parts in East Asia. In particular, this is the kind of specific example, how the different infrastructure on the left-hand side could contribute to the greenhouse gas emission. The biggest one, obviously, could be, as we know about the energy types of the power energy infrastructure, about 35%. And others also like buildings, right? Even the transport system, a bit less on water, waste management, and digital communication. This might be subject to the size of different infrastructure. And at the same time, this infrastructure could have different resource consumption and activity regarding the greenhouse gas emission. Then on the opposite, there could be the risk or the impact to the different infrastructure from maybe the same set here, energy to buildings. Then the risk here can turn into the cost we call like possible adaptation cost. We obviously could not reduce the cost to zero, but there could be some proportion from the damage and loss mentioned earlier into the adaptation cost that we might need to spend. And this also provides some kind of, at least order of magnitude that since the water infrastructure has more significant in terms of the cost for the adaptation and regarding also the loss and damage. Then the buildings still on both sides, mitigation or adaptation still play a quite major role. This might be something to look at, because at one point we want to deal with the greenhouse gas, or we call mitigation. At the same time, from the risk or adaptation, buildings play a quite major role. Also, if you look at another one on the transport system, on both sides, both maybe not very biggest from the greenhouse gas emission or adaptation cost, but the combination of both sides could be also a good way to focus in order to maybe provide some co-benefit, we call, from both mitigation and adaptation in the same transport infrastructure. And they provide some example here. We also very much like to see how any of these infrastructure, maybe from the climate change as something that are getting clearer, also linking to the local development. And this also based on one of our former PhD students, already graduated, to analyze the, we call the autonomous adaptation regarding the individual household development, which is quite typical in many suburban area, we call peri-urban area in this case. And this dilemma also important because every individual household have to adapt, we call autonomous adaptation, but at the same time provide some kind of something might be positive, but some might be quite negative regarding the local roads or local drainage system, because most of the each of the individual house here are going to basically pump the excess water out when they face with the heavy rainfall. This kind of the evidence also good to be provided and maybe share among different local communities. Then let me move on to the second part of the talk. Yeah, we very much need some approach which I focus from what we call the system approach in order to different goals which mentioned before. We have a total of 17, but we can even look at a few of them and how to link. And also from the infrastructure system, from multiple scale or user levels, including like policy, plan, program, and project. Another part that become more emerging, we call the trans-disciplinary and holistic approach. To look at from both vertical and horizontal types of the integration. And there are some of the specific approach and method which are widely kind of the utilized. For example, the eco-efficiency, cost-benefit analysis, multiple criteria analysis, life cycle assessment, ecological footprint assessment, sustainability assessment, strategic environmental assessment, environmental impact assessment, or social impact assessment. Yeah, these are some good examples, and I hope there are different publication or example audience could also look at. So move on. This is a good way to put into the guideline this by UN agency. How we can promote what we call the climate compatible infrastructure development. Among the three areas here, climate mitigation, adaptation, and different development goals. And it's quite clear that we need to look at development stage, some basic planning, and then we implement or call here delivery, and go into the management. Yeah, these three are quite important, maybe a bit different term from different reference, but we need this in order to deal with the management and development of the infrastructure. And quick example is a good reference to this publication based on the 2011 flood in the case of Bangkok. Utilize the system approach to have a better understanding of the cause and effect from different infrastructure and different sub area, upstream, downstream, and maybe a mixing of the nature and human activity to cause the great flood more than 10 years ago. Another example here, I quickly go through. This is a very nice framework to look at from the multiple scale, from the larger like city or the region to the neighborhood, district, smaller site or the block. So that we can map this spatial scale with multiple function or benefit of what we call here the urban green infrastructure. And this is emerging research, and we have some number of students moving forward to look at more detail. And it's good to, at least conceptually, we see some different significance of the function or the benefit at a different scale, at least some of them. And maybe among different benefit also show some different. This might not be the same from place to place or city to the city, but a very good framework to look at, and we need more and more cases to support this. Another way to be more holistic is to utilize this simple kind of the quadrant or kind of the X and Y axis to see how the climate change mitigation on the right hand side and make a climate change adaptation could be looked at. And I think quite simple that the audience could maybe select among the four quadrants which one should be better. And these are some good examples. That's why this part of the IPC report to see where we want to promote, at least on this part we call sustainable win-win. Example is simple water demand management, heat management in the buildings, not very hard part of infrastructure, but this provide a good way of we call sustainable win-win. And you could look at on other type of the quadrant. These two might not be too bad, but provide some kind of what we call the trade-off. But the worst case is about this one we call unsustainable, maybe not good for both mitigation and adaptation. Yeah, I have taken these two pictures by myself, and it's good to learn because in the two cities, one in China and one in Thailand, where we also conduct the research, have something very common. I was kind of very glad to see that the two cities maybe never met each other, but they utilize a very common understanding and the concept in order to develop what we call the adaptive flood protection types of the maybe mix between hard and soft infrastructure along river banks. Yeah, I mentioned about eco-efficiency. This provides a quick example in case some audience might not be familiar with. We normally look at the eco-efficiency simple way we call the achieving factor 4. Some colleagues want to achieve a larger factor like 10 or more, but factor 4 is somewhere that could be quite practical. And this kind of the series of component in the basics water supply, which link to the energy and power transmission, and get into very basic types of the pumping and piping. Any of these elements can be looked at from the eco-efficiency point of view. In other words, if we can reduce or increase the eco-efficiency by a factor of 4, that means we have quite big potential to be looked at in terms of the combination. And this another way to understand how the different phases of infrastructure development, from the planning, preparation, some kind of pre-operation, construction to the implementation, operation, and maintenance, could include a number of tasks, which we could look at almost one by one, and also require specific decision making. So each of these has a potential, because depend on the professional, which I end up my talk about the role of the professional in a different stage of the infrastructure development. We call the life cycle approach here. And one quick example, we are working on this project we call appropriate costing for climate adaptation of road and related infrastructure project in Cambodia. The idea is to quite holistic, maybe trans-disciplinary, from economic to maybe climate change to the infrastructure, in order to understand better how we do costing for climate adaptation of this infrastructure, so that this can be used to develop some kind of guidelines and go into a kind of pilot implementation or more practical implementation. So I will not go to the detail, but this is based on the earlier work, which have a good understanding of the road development cycle. And along this cycle, we try to turn into how each of the specific activities, from maybe very basic surveys, design of the road, to the construction, to the operation and maintenance, including like termination, could be looked at from the adaptation cost. That's mean we need to look at adaptation from earlier stage to the later stage. And any of this can be possibly converted into the monetary terms, so that we can use this as a common platform to deal with the decision making. Now, let me offer a summary of the challenge and opportunities. Yeah, I don't separate these two, but any of this can turn into either challenge or the opportunity, which many already mentioned in the earlier slide. So let me summarize. Some of these could be important from a geographical scale, like the even regions, to the country, to the sub-national, to the local. And yeah, there are both opportunity and challenge regarding this one. And also the temporal scale, at least short and long term. There are different sectors, not only infrastructure itself, and different urban and other sector to be connected. We also need to look at from the stakeholder and users. The next few slides we also show example how this important. And different function I just show in the recent slide about this different function or the benefit and also on the cost side. And more important is about development phases from the planning to the design. Then any of this from the challenge and opportunity can look into we call the both interaction and synergy or dis-synergy. From the analysis and integration of any of this, we could turn into the tools or the technique to monitor or evaluate the interaction and also the synergy. For the specific sector, maybe some feedback from the floor. These are some of the sector from climate mitigation, resilience, urban and transport, green infrastructure, including the social infrastructure, could be kind of the priority topics to do more research and obviously to turn into both policy and practicalities. Yeah, let me go through quickly on some of the example. This is from IPC report, collecting the record from different city, how they utilize the idea of the climate mitigation in different sectors, right? And this could be by supporting the earlier slide, the allocation of different infrastructure from climate change adaptation. From the resilience, we do have options from very basic coping to incremental to the what we call transformative. And any of this could provide both maybe pro and cons, but there are some ongoing research to see maybe some combination or the selection of this different approach of the resilience. One quick example from also our former student, analyzing the accessibility to the metro system for the case of Bangkok to see how maybe different dimension. In fact, this is a quite very new research that time since 2012, and a different group of people from men, women, elderly, and disabled people provide a good feedback on this multi-dimension understanding among also different station of the metro. And this is another good example of our former student research from Mandalay. Look at the multi-stakeholder and multi-benefit approach in order to enhance utilization of public open space. It's a type of green infrastructure. It's good feedback from the user, how they see multiple benefits. And this turn into the attention of the mayor or the management of city, how they can make use of this in order to enhance the existing public open space. So let me end with a way forward here. To be a bit precise, I see that these are something that could be looked at. The first part, how we can enhance accessibility more to the basic infrastructure and service, because this can provide very good rationale. When we talk about climate change, we talk about any kind of emerging issue, but basic accessibility still need to be looked at. And this very much linked to different other type of activities of the population. To go into more advanced, why don't we look at maximizing, it's called a co-benefit of different development and management, from maybe two types of benefit to be more multiple. And there are some examples which mentioned before. The next one is about ensure social and environmental sustainability. This still will be ongoing from the past, and now we have maybe more challenge in terms of the multiple scale of this what we call sustainability. And last but not least, maybe the emphasis of what before I end the talk, what would be the role of a professional, and emphasizing in the different stage of development cycle, from policy and example like planning, etc. And I put it here, what would be the role of planner and engineer? Yeah, we could see that at least conceptually, these are important because we see a lot of linkage. We see the gaps of understanding from a different scale or different function. And I believe this is a good part of planner and architect to contribute. The engineer can do, I think, many parts, but from the detailed planning to basic construction to reduce the impact or enhance the positive effect until maybe some kind of the operation and maintenance subject to the types of engineer to contribute. The manager can see overall of what we are talking about, but depend on the types of manager, from the upper to a bit middle or lower level of the managers might have different roles from the planning to the implementation or the operation, and different types of the operators. We should not overlook this part. I think many of the literature and some of my own experience, we focus quite a lot on the planning and design. But when we go into the operation and maintenance, which literature also tell, and the real effect also quite a really long run. Most of infrastructure have to be operated for how many years? I think that's quite clear. And yeah, we perhaps can improve a very low percentage of this part because it's challenging, but the longer period of the operation could maybe contribute more. So I perhaps like to stop here, and very much like to see here any feedback or question from the floor. Thank you so much.